Hello, grade 12s. In today's lesson, we'll be looking at the geometric sequence. Let's get right to it. So we are given that consider the following geometric sequence, which has 4, 12, 36. And then the first question says determine the general term. Second question, which is number B, says determine the seventh term. And then the third one says which term is actually going to be equaling to 78,732. So when we talk about a geometric sequence, we're talking about a sequence that has the following general term, which is a, r, n minus 1. So let's jump right to the first question. Now consider the sequence and then determine the general term. Now we're going to be using the fact that all geometric sequences have the same general term, which is a, r, n minus 1. Now basically, for us to get this, we need our a, which by now we know according to the geometric sequence, our a is actually going to be our first term, which is going to be 4. The other thing that we need is our r. Now how do we get r? We're simply going to say that r should be given by T2 divided by T1, which should give us 12 divided by 4, which end up giving us a 3. So our constant ratio, since we're talking about a geometric sequence, is a 3. Now if we're going to write our formula, it says we're actually going to have our a, which is a 4, and then we're going to have our constant ratio, which is a 3, and then we have n minus 1. Now we don't multiply it through because the exponents are not the same, so this is going to be our answer. Now we move on to the next question, which says that determine the seventh term. Now how do we determine the seventh term? Again, we're going to use our general formula, since we know that Tn is going to be given by a, r, n minus 1, which means that we are looking for T7. Then we have our a, which is a 4, and then we have our r, which is a 3, and then instead of n, now remember, we no longer have n, we've changed our n. Instead of n, we have 7, so we're going to have 7 minus 1. And then if we type this in our calculator, it should give us something like 2, 1, 8, 7. So this is going to be our final answer. Let's move on to the next question, which says that which term is going to be equaling to 78732. Now, in other words, we are given the value, we're looking for the position, which means that Tn should be 783. Oh, sorry about that. It says 78732. Now, we say our general formula says 78732 should be equaling to 4 multiplied by 3n minus 1. Now the first thing that I'm going to do here is to divide by 4 both sides. Divide by 4, divide by 4. Now let's put our Casio calculator up and see what do we get. So we have 78732 and then we divide that by 4. We get our answer as 19. So we got our answer as 19. Go back to the answer again. It's 19683. Which is going to be equivalent to 3 and minus 1. Now, from grade 11, we know that if we are dealing with exponents, we need to change 19683 into a prime product. We're going to do that from our calculator. Again, let's go back to our calculator. And then we say equals to shift, and then we say fact. It says it can be written as 3 to the power of 9. Let's go to the next page. Then we have 3 to the power of 9, which is going to be equivalent to 3 and minus 1. Now, since the bases are the same, we drop the exponents. It says 9 should be equivalent to n minus 1. Take the one to the other side. It says n is going to be a 10, and therefore T10 is the one which is actually going to be equivalent to 78732. So that's it for today. Thank you.